So we just got done talking about end behavior and continuity, right?
Yes, sir.
Now we're going to talk about another part of a function, and that is and average rates of change. Average rate of change is just a different way to say slope.
Is that what I should title my note for this? Extrema and average rates of change?
Yes. So here we are. What does it say? It says we're going to talk about first increasing and decreasing behavior. Functions can increase, decrease, or remain constant over a given interval. The points at which the function changes its increasing or decreasing behavior are called critical points. Critical point can be a relative minimum, an absolute minimum, a relative maximum, or an absolute maximum. General term for minimum or maximum is extremum or extrema. Did you get it? All done, right? I can move on.
The graph goes up.
Does that make perfect sense?
No.
No. Fancy language, right? Fancy language. And so when we look at a graph, and I'm gonna blow this up a little bit so we can just look at a graph. Wherever I put that little pen. Here we go. Really blow it up. All right. Come on.
Extrema.
Okay. I think I understand now, sir. I just had to read it for myself.
So it's minimum and maximum.
Minimum and maximum is called the extrema.
Mins or maxes, right? All right, so let me go to this little graph. Oh, yeah. This little graphy guy. Right, there you go. So, we're going to label it all. You don't have a chance to label it on yours. It's very, very small. But let's take a look at this big graph. When we talk about increasing or decreasing behavior, we start from the left and we move to the right. Okay? So here, if we're following along the graph, what are we doing? We are increasing, right? So we'd say that this graph is increasing from negative infinity all the way over here to negative 1, basically. Negative 1, basically. And then what does it do? It turns around. Right? It turns around and starts decreasing. So now it's decreasing from negative 1. Oh, I'm sorry, you were right. Closer to negative 2. So past negative 1, probably about negative a half, and then starts increasing again, and then decreasing, and then lastly increasing. So that's pretty easy to see, right? Everybody gets that. That's not a difficult concept, because if you drew an arrow next to it, you'd see, is it moving up or is it moving down? There you go, right? Now, where it turns, it says on the paper, where it changes direction, that point is called a critical number. Now, we're not going to deal with critical numbers in this class, but if you have to take a calculus class, critical numbers are your best friend, right? So where it turns right here is a critical point or a critical number, all those turning points, right? Where it changes from going up to going down. Good? We also call these extrema. There are two types of extrema, or two types of extremes. Two types. There's the absolute and the relative. And they describe both minimums and maximums, maxes and mins. Okay?
What's the definition of it?
Sorry?
So what's the definition of it?
Where the graph turns,
Okay.
that critical number. I'm going to show you how simple it is to figure relative and absolute extrema. Now, if it's going up and turning down, it's on top, right? It's on top of this bump. So this is a max. Whoops. A max or a maximum. It's going down and then turning back up. This must be a min. Right? It's going up and then turning down. It must be a max.
What a max.
Because it's the top of the bump as opposed to the bottom of the bump.
Okay.
Bottom of the bump, top of the bump.
So it's the top that is max, it's the bottom is min.
Correct.
Okay.
Now, any part of this graph go past this max?
Yes.
Yes. You're right. Right? Because this goes up infinitely, right? Any part of this graph go past that minimum?
Yeah.
Yeah. So all of these are relative maxes or mins. I'll show you an example right here, but you already have one on the. Rel max, rel min. Now I'll give you an example of an absolute maximum. Any part of the graph go above this point here? Any part of this graph go above that point right up there?
No.
No, so therefore it is the absolute top or the absolute maximum Y value.
Oh.
Pretty cool? Is this the absolute maximum Y value that you have in this function? No. So it's got to be a relative.
Sure, so, that's equal for absolute, what is it, max Y value, highest Y value?
Yeah. This has both. This has both an absolute minimum
I keep that.
and a relative minimum. Because it is the bottom where we turn around, right? But there are points lower on the graph. There are no points lower on this graph for this guy here. So that is an absolute. And just because my camera's not facing the right way, I'm going to go back and point it out again since I drew it and we can't see it. So, absolute maximum, relative max, relative min, absolute minimum can also have a relative minimum in the same function because we know that this graph goes lower, has a lower y value.
Sir, on that bottom left graph, it says relative minimum or max?
Here,
The top point.
max. Sorry. Let me write it out a little bit better. Gotta get a new marker. This guy's dying. this guy's better. Should be. Yeah. That was the tough part. You guys okay with that being the tough part?
I just need one more explanation, like the difference between relative and absolute.
So absolute means there are no other y values in terms of, let's talk about absolute maximum. This absolute maximum here means there are no other y values greater. If I had a graph that looked like that, this is an absolute minimum. There are no output or y values less than that. Yes?
So does the absolute max or minimum have to be plotted? Like, so because, all right, isn't like the relative max just gonna always be like the absolute max? Because it's like y is pointing back.
No. Well, look at this graph here that they've given you, right?
Yeah.
There are no absolute maxes or mins at all there, right? Because the graph's ends, that end behavior that we talked about previously, is infinite in both directions.
Ah,
So there is no bottom or top to that function because it extends out infinitely. Better? We'll have better examples. All right, so if we look at this graph and we look at this, how this is listed, it says it appears that this function has a relative max of 0 at x equals -1.5. And that's how you list it, right? So if you have a highlighter, highlight this, highlight this, you guys have a highlighter?
yes, sir.
Should I find them?
Yes, Mr. Sokol.
Here you go, sir. Here you go, sir.
No, use it.
Oh,
Use it. I have a highlighter.
sir, you have to tell me stuff like that.
Everything I just underlined is what you should be highlighting.
You better tell me stuff like that, sir. It's not like it's gas.
Bad?
No, it's gas. It's good.
Gas is good.
It's one of them like gas
Learn
ones.
something new. Gas is good.
If I told Coach I'm not sure you'd freak out.
Where are the flippity flop that I put my highlighters? There's a whole bag of them. They're over here. Who doesn't have a highlighter? Everybody has one?
Yes, sir.
Alrighty. Then why am I back here looking for highlighters?
Oh,
Got one, Thomas?
My eyes were just.
When do you use this one? Thomas? Are you?
Got one?
no.
Everybody else is good, right? Alright.
See, that must have.
Now, sometimes, when you're just looking at a table, you can figure out where there is some sort of maximum or minimum, right? We know where it changes direction, right? This is way down there. comes up, it gets almost to 0, and then turns back down. So between here and here, it was coming up, and now it's going down. So there's a relative max. Right? So it's going down, 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 but it looks like it's turning back up now, right? Because -3.5, 2 to -3.5, we're going down, but -3.5 back up to -3, now we're going back up. So there must be a relative min here. It's going up, and then it turns back down. There must be another relative max here. It goes down, down, and then shoots back up. And so there must be a relative min there. Is that okay?
Are we allowed to ignore the 1 times x to the 10th power?
It's going on.
Why?
I don't understand.
Why are you going to ignore it? Well, what's 10 to the 10th power? It's pretty big, right?
100. Or like, I don't know.
It's really big
Really, really big.
and really small. Okay?
10 times 10 times 10 times 10 times.
Yeah, it's just a 1 with 10 zeros on it. Good? All right.
10 zeros.
So now you could explain intervals, right? Most of the time, I'll have you looking at graphs. Hopefully, if they did this right, there are graphs available for us.
You understand?
Where is it? There it is. Been a long time.
You're gonna be an engineer.
Ah, nuts. That doesn't help me at all.
No quiz, Mr. Super.
Well,
Chair, you cool?
all right.
I think he needs a PT session.
He does.
Does everybody have a calculator?
No.
Phone went in.
Well, there are a bunch of calculators out there. Everybody should have one.
So I don't need calculator.
Or Desmos. Why do we need calculators? Because we're about to graph this first function. 2x to the 6th plus 2x to the 4th minus 9x squared.
Wait, sir, how do I clear the graphs?
Oh.
They already used.
When you go to y equals, just hit clear.
Yep, I'm pressing that, but it's not clearing.
Second.
Just start hitting delete a bunch.
You have to press second and then vote.
Thank you.
Yo, that song was made for you, bro.
What you mean?
Minus the girls part.
You know, I learned to dance yesterday.
So you swear, hey.
I swear.
I might
Nah,
have to
show
rub
me,
up on
right?
my bed.
For what? What dance?
We should make the TikTok.
What dance did you learn this?
You heard the it's cold outside?
Yeah.
Okay, it's a W, sir. It's in the
So it should look like a W, right? When you get there. Graph away. Stop talking about learning to dance and graph away.
You can't dance.
All right, just about.
I didn't ask.
Ew. He said that. He said that.
This is what I got.
So I ain't gonna lie, I forgot how to grab.
You forgot how to excuse me?
Press the Y equals. Then the don't matter, press the Y equals. Top left, very, very top left. Then put in.
Yeah, 2.
Oh,
And then
I think I called it
all that
relative, so
graph.
the ones at the bottom, since they're at the exact same point.
Look, you see X, look, right here, right here, right
oh, interesting. I word. Somebody listening.
here. You know how to do it?
Oh, wait, Henry. Oh, no, I got it. Delete.
Yep, that's exactly what I did.
No.
Should look something like this.
Yep.
Potentially opportunity.
Good?
Let's see.
It touches the, gets to the origin. Okay. Now, there is a min here. And there's a min here, right? Yes? Yes? If you hit second, the blue button, and graph, they'll give you a table. And if you look at -1, what's the output?
0, no negative.
Wait,
-5, right? So this is -1, -5. If you look at 0, what do you got?
0.
0, 0. And this last one is 1, 5. It's symmetrical, right? Oh, sorry, 1, -5. Pardon me. Look at that.
Nice.
Does the graph ever go below -5? Look at it. Does it ever go below -5?
Oh, no.
Yes.
No.
When?
No.
When does it go below -5? It doesn't. Get right up on top of it. Right, so it never gets below -5. So these are both what types of minimum? Never goes below it. What types of minimums are there?
Oh, wait, let me see.
Absolute.
Relative. Absolute. Absolute? Oh, yeah, because they don't. Never mind. I know why you don't have to tell me, sir. I know why.
Absolute minimums, right? Of -5 at x equals -1 and 1. So it has two absolute minimums. Now, this maximum here, does the graph ever go above 0? Is there ever an output greater than 0 on this graph? Yeah, a bunch of them, right? Goes up infinitely. So would that be an absolute or a relative maximum? Absolute or relative? You said it. Relative. So the graph has a relative max of, what's the output? 0 at x equals 0. So that's how you're going to list it for me. That's what an answer looks like on a test.
Okay, so this is where I have to write the test.
Yes.
Whoa.
So can you show me how to graph on this calculator, please?
Yes.
These are notes on the test sheet.
No. Why would you use your notes on a test?
You know, open notes.
No.
You know, compromise.
Learn it. What are you having trouble with?
Every
Yeah,
time
you show
I-
me too.
So I press
Show me
this.
too.
Yeah, but why don't you hit y equals to create?
First, I gotta learn that this.
Put a function.
Today, I gotta learn that this.
You know the song I'm talking
That's what I
about?
was missing. Thank you.
Yeah, so that's where you can hit, if you go here,
It's cool.
right, that's where you can hit your two x to the
What's to the,
six.
what's that?
That little caret.
Oh.
Thank you so much, sir.
Oh, no problem.
Little carrot, oh, I see.
That's how you get to the sixth and to the fourth. The only one you can do without hitting that button is squared. Desmos is easier because you can actually just type the number.
I think I got that in my Safari right now.
Right on?
Can I use Desmond like for a time?
Sure.
Okay.
Wait, green says you use those? Or this?
Alright, bro. See?
Sure.
Okay.
But the first person who cheats, everybody loses. Everybody fails.
Oh,
How's that?
alright, that's.
Is that awful?
Desmos is way better than calculator.
Yeah, Desmos is easier to see. You can't even see these functions. I'm looking at the video. You can't even see these functions. Good thing you have that paper.
Sure, just check everybody's history after the test.
Oh no, I'll just
Whoa,
watch.
whoa, 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 whoa.
You guys aren't that smart. You think you're smart, but you're not. I'm too old. I've seen it all, man.
But you don't. Wait.
Are you the man behind the?
I know y'all are cheaters. It's good.
I'm not.
It depends, sir. I feel like I only cheat in a teacher's class who I don't have respect for.
I disagree.
Like Mr. Austin, for example.
You wouldn't cheat in his class, right?
I think he's saying the obvious.
Get out of here, sure. Oh wait, is that on record?
All right, I am putting.
Oh shit!
I'm running. I'm putting the next function in.
Yes.
Hey,
All right, bro. Hey.
yo, we're not starting this shit again. Not this year. No.
Chill out, man.
Oh my god. Oh. Sure, I'm gonna have to call you mess.
Yo, wear a mask.
What you doing?
Put some hand sanitizer.
No, bro, that shit, I see you laughing, bro. That shit's so disgusting.
That was pretty bad. All right, so let's put this bad boy in. Let's put in x cubed plus 9x squared.
Oh, so I already did it. It looks like a normal.
It goes like this, right?
Yeah.
Very nice and neat.
Seriously.
Poopy. All right, so I have to go to the table, figure out where it pops out. Okay, 108.
You know, like this.
I mean, my shit look.
Okay.
Yeah, you go all the way up into the last game. 108.
Goes like that, right?
Oh,
Only this is really, 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 really high.
Oh, I seen that line. I was trying to figure out what that line was.
This is, if we really graphed it, this would be way up here.
Yeah, it's like 108.
So it has a relative maximum between -6 and -5. I think it's right at -6. Yeah, right at -6. So it has a relative max of 108
It's -6.
at x equals, was that -6?
Yeah.
-6. And then it has a relative min of what? What's the y value here at 0, 0? Yeah, of 0 at x equals 0. So that's what I want to see on some sort of test. Sound good?
Yes, sir.
Right on time.
Oh, damn, sir. All right.
Perfect timing. Wow, how did that work out? Where's the papers? You three, I'll hand you your homework on your way out the door.
Is it hard, sir?
Yeah.
Sure, I just know that, oh, because it does. My calculator would have shown that.
Yeah, my calculator showed it, but
Yeah,
it
it only showed like half of the thing. Like, cut off.
At the top
I think my notes are very nice and deep.
So, all I want you to do for 1, 2, 3, and 4 is tell me what the maxes or mins are.
Oh, not on the back.
No, the back is for tomorrow. The maxes and mins for 1, 2, 3, and 4. Okay? You're gonna have trouble with 2.
I'm gonna write that down.
Infinite nonsense.
Somewhere around.
Here you go.